Okay, so here we are, and Suzanne Von Oy made this amazing Desmos program. So what do you see on the screen right now before we even start playing with it?
So we've got the lines that pass through A, B, and C.
Okay.
I think the equilateral triangle is right here.
Okay, and what's special about that equilateral triangle?
So...
Can you tell me?
So, it has sides, three random points. And then this,
yeah, so the three random points, I don't know, hopefully it shows up well on the screen, but it's A, B, and C are the three random points.
So, each of the sides, so this line here passes through point B here.
Okay. But it's not the fact that the line passes through point B. What has to pass through point B?
The side.
Of?
The triangle.
The side of the triangle has to pass through point B, yeah.
So, and also, that's the same for A and C.
Okay, so where's the equilateral triangle here?
So it's right there.
Okay, good. All right. All right, who wants to play with this first then? You? Okay.
I got it.
All right, go ahead. So you can move the angle. So what happens when you move the angle? What do you notice?
Well, the triangle sort of rotates from, here's 0.
Okay.
Here I'll go like to 0.5-ish.
All right.
It's spinning sort of counterclockwise.
Okay.
It's also getting bigger until I think here it starts to get smaller, maybe around 1.
All right, yeah, the numbers, don't worry about the numbers.
And then looks like here looks like maybe at its smallest. That's sort of interesting.
What is interesting? This is probably a little too small to see.
I'll make it a little bigger.
All right, so there. All right, go ahead.
So it's pretty small. It looks like it's small when
What is
this
small?
equilateral triangle is small when C is the line passing through C has this shallow slope, like it does now.
Okay. Wait, don't change anything.
Okay. And
Can you tell me anything about this?
Well, it doesn't satisfy the conditions
Why not?
because the points A and C aren't in the sides.
Ah. So this setup doesn't satisfy the conditions of the problem.
so maybe this problem, maybe for 3 random points, maybe there's not an equilateral triangle passes through them.
Okay.
Well, there's definitely lines that pass through them.
There definitely are lines that pass through them, but this situation doesn't work.
Yeah.
This one on the screen doesn't work, but can you make it work?
By moving the points around?
Nope.
Or change this. So that, like here, for example,
Okay.
works.
All right.
So it looks like there technically are infinite triangles passing through
All right. Why don't you?
these 3 points.
Why? Why do you say that there are infinitely many?
Well, you can like change this angle that we're using by an infinitesimal amount. It creates a different triangle,
Uh huh.
and it still works.
Okay.
And
Can
they-
you do that? Can you change the angle by a small amount? Yeah.
You can take it by like
Yeah. Or just change it by a small amount again. Okay.
it
So
actually makes a considerable difference.
does it?
When you're changing by like increments.
Yeah. So how does that tell you there are infinitely many?
Well, you can just change it by a really, really small amount, and that will get you a different triangle each time.
Okay.
Because there are infinitely many.
Yeah.
Infinitely many
It's really cool.
integers.
So why don't you move one of the points around now? Move a point somewhere.
So how about I move point A out here? Line.
It's not like changing much.
Okay, well, you're right. So your brother's saying that didn't change much. Change this to an illegal place. Change A to make it illegal.
Make
the point. All right. So now we have an equilateral triangle, but it doesn't pass through.
Well, I've noticed that the slope of A does not change.
Oh, interesting. Okay, so you notice that the slope of that line passing through A doesn't change. Okay, but we still don't have. This doesn't work. So maybe this situation doesn't work.
Well,
So what do you think?
We can, if we can change point, if We can change points B and C too.
Well, but this is 3 random points.
Oh, so.
So maybe we can change the angles a bit.
Okay.
There.
There, this works. It's a little off screen.
It's off. It's all right. It's off screen. The equilateral triangle is very big, but it worked.
Yep.
And are there infinitely many passing through these 3 points?
Yes. Because again, you can just change the angle by an infinitesimal amount.
Okay. Now move one of the points one last time to some place that doesn't work.
Move it move C really far out, or move C down,
Like, really?
or you can move it.
No,
Yeah,
none of them work.
Oh wow. Okay, so now the equilateral triangle isn't there. So do you think this situation works?
Yes, I still think you can make this work.
Okay. All right. Move the angle around. See what happens.
Start at 0. Do we ever see a situation where the triangle?
Huh.
This is great. Actually, hold on. We're at 6 minutes. I'm going to go to the next movie. Wait just a second.